I'm going to take a look at how Newton's second law can be integrated with inclined planes. So if I've got a slope, they tell me that it's at 40 degrees to the horizontal, and I've got this block that's been put at the top of the slope, and it's a 12 kilogram. A 12 kilogram block. And I'm told that this whole slope over here is 5 meters. So this is not a force diagram, this is just all the information kind of diagram. I know that if I have a weight acting down there, it is going to be 12 times 9,8, and that turns out to be 117,6 newtons. I'm also told that there's a frictional force of 60 newtons up the slope. What other information can I get? If I'm going to now take a look at this and break it into its components, this component, I can put 40 degrees in there. The component that is adjacent, I'm going to say cos of 40 degrees is equal to my adjacent side that I don't know over my hypotenuse, which is 117,6, and I find that this adjacent side over here turns out to be equal to 90,09 newtons. Simultaneously, if I'd like to work out this component over here, I'm going to say sine of 40 degrees is equal to the opposite over 117,6, and I find that my opposite side turns out to be 75,59 newtons. The question is, what is the acceleration of the box? Well, if force resultant is up and down the slope is equal to the big force, which is whatever's going down the slope. What's going down the slope? 75,59 is going down the slope because this component of weight is actually acting down the slope. So that's my big force, and I can go 75,59. My small force is 60, and therefore the resultant force on this particular box is 15,59 newtons. That's equal to the mass of the block times acceleration. We know the mass of the block, it's 12. And therefore, when I divide 15,59 by 12, I land up with 1,299 meters per second squared, or 1,3 meters per second squared. Store that number in your calculator because you're going to need it later and you'd like it to be as accurate as you possibly can make it. The next part of the question asks, how long does it take for the box to reach the bottom of the incline? Now I need to look at equations of motion. I've got a distance, I've got an initial velocity, it starts off at rest, and I've been given a I've been given an acceleration, I've worked out an acceleration. So I'm going to use S is equal to ut plus a half at squared. 5 is equal to 0 plus a half. I don't know the, I do know the acceleration. It's this 1,299 that I just saved in my calculator. Don't forget to square root, and I find that time comes out to be 2,77 seconds is the time it will take for it to reach the bottom. And finally, what is the coefficient of friction? If I want the coefficient of friction, I'm going to go and I'm going to say friction is equal to mu force normal. Friction, I've been told, is 60 newtons. I don't know the coefficient of friction, but I do know the normal force. Remember that that force is exactly equal to the normal. So I can substitute it in 90,09, and I find that my coefficient of friction turns out to be 0,67. Coefficient of friction has not got a unit.